Today we're going to talk about the remainder and factor theorem. This is putting together what we talked about with graphing and what we've talked about with factoring and how they relate. So the first thing I want to show you is before we jump into the notes. Before we had talked about things, I maybe gave you a function like f of x equals x plus 3, x minus 2. And we looked at that and we said, okay, well, what are the zeros of that function? And we said the zeros are the opposites of that, so -3 and +2, which meant that our graph had intercepts at -3 and +2. And then we used that information to finish graphing it. We looked at like, well, what's the degree of the polynomial? It's just degree 2, so it's even. The end behavior then is going to be up, up. We could plug stuff into our chart and find, if we plugged in like 0, we would find out that we would get a negative value. So we know it looks something like that. So we did that before in previous lessons. Now what we're going to do is kind of go the other direction from it. But we already know this thing from before. If we know a 0, if a is a 0 of a polynomial, okay, if it's one of these x-intercepts, then x minus a is one of the factors. So if I tell you that -3 is a 0, that means x plus 3 is a factor. If 2 is a 0, x minus 2 is a factor. Okay, so it's always the opposite sign there in the parenthesis. So we can actually use that to find factors. So I have this polynomial equation. Now, if I asked you to factor this thing, you couldn't do it. We can't factor by grouping. It's too hard. But we can use the graph of it to factor it. So I've put this on Desmos already, and we want to find the factors. So we can see that this 0, it looks like it's -6. So that means one of the factors is x plus 6. Looks like we have another 0 at -3. So one of the factors is x plus 3. We have another 0 at 2. So we have x minus 2. And our last 0 is at 4, so x minus 4. So without having to do any work, we have been able to factor this degree 4 into its 4 factors. All right, let's do this again on the next one. This time I didn't even give you the equation for p, but it's graphed here. So it looks like we have a 0 at -4, so that factor will be x plus 4. Looks like -2, so x plus 2. +1, so one of our factors is x minus 1. +3, so x minus 3 is a factor. And +5, so x minus 5 is our factor. Okay, now you may not be always given a graph. So suppose you are given that x plus 1 is a factor of this thing. Okay, we want to find the other factors and then sketch the graph. So all we know right now is that x plus 1 is a factor. So we know that on this graph, it's going to cross at -1. Okay, that's not a whole lot of information. All right, now, if x plus 1 is a factor, that means it divides evenly into this, okay? Because that's what factors do. Like if I tell you that 3 is a factor of 45, that means 3 goes into 45 evenly. So that's what we're going to start by doing, is we're going to start by dividing this. We can use long division or synthetic division, but either way, we need to take our original function and divide it by the one factor that we know. I kind of prefer synthetic division, so I'm going to do that when I can. So my coefficients are 1, 2, -1, -2. And in the box, I'm going to put the opposite of x plus 1, so -1. All right, we multiply and add, we multiply and add, and we multiply and add. So when we do that, we call this thing the depressed polynomial because it's 1 degree less. We started with x cubed, so now we have 1x squared plus x minus 2. Now let's keep factoring that. So finish factoring this. This is going to factor into, the signs are different. things that multiply to -2 and add up to 1. So those are the other factors. Remember, we were told that x plus 1 is a factor. Now we know that x plus 2 is a factor. So one of the zeros, another one of the zeros, I guess, is -2 and 1. So now we know that it's -2 and 1. This is a degree 3. It's got 3 intercepts. It's degree 3, so we know the left and the right hand end behavior. Degree 3 with a positive leading coefficient, the left is going to be going down, the right is going to be going up. So we know that. And then to finish this out, we could set up a little table of values and plug in like -1.5. If we plug in -1.5, I think we get something that's positive. You're plugging it in up here. If we plug in 0, we're definitely getting something that's negative. So we know that this graph looks like that. We'll check out some more examples just like this in the next video.